Hi, everyone. Great to be with you today, and welcome to today's session on recording SSH activity with Boundary. My name is Robin Beck. I'm really happy to be with you today. I'm a senior product education engineer here at HashiCorp, and I work primarily on Boundary and the educational content associated with it. So thanks for joining us. So a little bit about this session. This is a hands-on learning session. If you want to follow along, I really encourage you to do so if you have your laptops. If not, the content will be available after this session for you as well. So you're welcome to take this content home with you and try it there if it's more appropriate, or if you have any trouble with the lab environment today. So a little bit about the agenda. We're going to go over just a brief introduction to Boundary, what it is, a little bit about how it works if you've never seen it before, since it is one of our newest products. And then we're also going to discuss a little bit about some of the features that we're going to be demoing today and how they're accessible using HCP Boundary or Boundary Enterprise. We'll talk about what session recording is, the feature that we're going to be demoing today and give you a chance to try out. And then we'll jump into some of the prerequisites and, of course, do a hands-on lab. We'll try and leave some time here at the end of the session for Q&A and questions you might have, and that will be the session. So I like to start this out by giving you a moment to get started before we jump into a little bit of kind of the prerequisite materials that we like to cover first. So because today we're going to be demoing some of the enterprise level feature sets for Boundary, we want to first make sure that you have access to Boundary to get started. So the easiest way to get started with Boundary is to use HCP Boundary in the case that we're going to be demoing some of our kind of enterprise level features. You can absolutely use a development environment on your laptop, but for the feature set we're going to be using today, you'll need access to an enterprise level version of Boundary, which is why we recommend starting with HCP Boundary here. So if you haven't signed up for an HCP account yet, I'd love for you to go ahead to this link, portal.cloud.hashicorp.com, and sign up if you haven't already. You will be able to complete today's lab content for free. So you won't have to worry about paying for today's session if you get started. So if you haven't signed up, go ahead and do that. And I'll give you a chance to see what this looks like here in a moment. But if you haven't already, it'd be great to provision a new HCP Boundary Plus cluster. So right there at that URL, go ahead and step through the process for deploying HCP Boundary, and you want to make sure you select Plus when you deploy it. I'll show you what this looks like here in a moment if you've never done this before, and this will just get you ahead of the curve once we get to the lab material in a moment and give that cluster time to provision. So while you're getting started with that, I want to just talk a little bit about what Boundary is for those of you that this might be completely new to. So to facilitate this, I wanted to walk through a little bit more of a traditional workflow for accessing infrastructure resources remotely. And in particular, typically users are going to connect to their infrastructure using a VPN and then use some sort of SSH bastion host or jump box that allows them to go through their firewall and finally get access to the hosts or services that they're trying to get to. But there's a number of challenges presented with this workflow. The onboarding and offboarding process in particular can be quite challenging, and it's often manual at a lot of organizations. And this creates a bottleneck for administrators, such as senior DevOps or SecOps leads that are responsible for that process. You have to sort out routing, access lists, etc. And once the user has been authenticated using their VPN and they SSH using a jump box, which itself needs to be maintained, then you increase your attack surface by exposing often the entire network to those users that are connected. So firewalls are usually the first line of defense here. And they need to be put in front of target hosts to ensure access is only granted to that jump box. The issue with these firewalls is that they operate on IP and port identities, and it doesn't scale in dynamic environments where IPs are ephemeral. So when a user finally reaches the database or server that they're trying to get access to, they've already obtained some sort of static credential set, which is most likely pulled from an Excel file living somewhere, which really increases credential sprawl and contributes to the likelihood of a breach down the line. So Boundary is our answer to this kind of challenge. Boundary is going to automate the access to critical infrastructure resources wherever they reside, and you can kind of think of it as a jump box replacement. So firstly, when the user logs in, they use a trusted identity provider like Okta, Azure Active Directory, or GitHub. This integration with Boundary is going to help authenticate users, and it removes much of the friction associated with onboarding or offboarding employees, because once the change is made in your IDP, it's reflected within Boundary. This level of granular user authentication helps authorize which systems users can access and the actions that they're allowed to take based on their role. So next, Boundary automates the connection to those hosts for users through continuous service discovery and access configuration as workloads are deployed or updated, and then presenting them with a catalog of all the available applications or hosts that they want to access. These dynamic host catalogs are critical in cloud-based environments, where IPs are ephemeral. And operators don't have to be constantly updating their access lists. When a user decides to access a host or a service, the native integration with tools like Vault provides them with just-in-time credentials and that are never exposed to the end user for that particular session. And since Boundary is acting as a time-limited proxy to these private endpoints, you avoid exposing the entire network to them. So this is our solution to this problem that VPNs often present. So we're going to give you a chance to try this out today. And there are a few different deployment options for Boundary that we want you to be aware of. The first two here have to do with deploying Boundary using HCP, our managed cloud service. And with HCP Boundary, we give you a couple of options for how you want to deploy this infrastructure. First, you can let HashiCorp manage the entire deployment for you. We have two real pieces to a Boundary deployment that you have to manage. One is the controller, and then the other are workers. And we'll show you a little bit about what these two components do in just a moment. And on HCP Boundary, you can have us manage both the controllers and the workers for you. But a lot of organizations need to have a lot more control over where their traffic is routed. And if you need to have your traffic routed through your infrastructure instead of managed or routed through Boundary itself, then you can manage what are called the workers for Boundary. You can still use HCP Boundary and have us manage the control plane for you, but then you can control the traffic yourself by managing your own workers so that you can securely access to private endpoints without exposing your network to the public or to HashiCorp's network resources. And then you can also, of course, manage everything yourself using our Boundary Enterprise or Community editions. And this is where you control the data plane and the workers and manage them yourselves. So here's a little bit more about what workers are. What are a worker? So this is a very basic example of what the components are from any Boundary deployment. First, we have the control plane that you can see here. The controller is what is responsible for authorizing sessions to your targets. So the main things I want you to pay attention to in this diagram are the idea of a user or a client and the target over here that we're trying to access. And the controller is responsible for authorizing sessions that end up being routed to the targets. We have the data plane itself. It's made up of our workers, which are going to route the connections to the target that's in some private network somewhere that we're trying to access. So controllers decide if users are allowed to authenticate to the client, and they contain Boundary's resources and permissions. And they also might be speaking to external components, such as databases, KMS, Vault, identity providers, etc. Workers are then used as these network proxies for Boundary sessions. And they allow you to access private targets. So instead of exposing private networks to the public or allowing users to have access to the entire network, workers create this direct tunnel between users and targets. And what you're seeing here is an example of what we call a multi-hop scenario. So if you do end up learning a little bit more about Boundary in the future, we can chain these workers together to provide deeper levels of network access and reach targets that are buried deeper inside of the network. We call these multiple hops to reach these targets. So using a reverse proxy tunnel, we have these 3 separate workers that can provide access to the target. We have our target living in the same network as what we call an egress worker. And then we have a couple workers placed in the chain before that. We have an intermediary worker and then an ingress worker that receives that initial connection from the user. And you can have more workers in this chain as well. This is just an example. So this is the function that workers serve, and this is pretty key to understanding how Boundary works. So when you try this in the future, you'll need to be aware of what a worker is and what it can do for you. And we're going to set one up today. So again, these HCP Boundary versus Boundary Enterprise, and Boundary Enterprise. I want to help you understand a little bit more about some of the features that you're going to get if you utilize HCP Boundary or Boundary Enterprise. The first is your identity-based access management to critical infrastructure. And so this workflow allows operators to define a group of resources and identities under management. And then roles with granular permissions can then be created that outline which targets users can access. And when a user is attempting to access a host or a service, we can provide a native integration with Vault for just-in-time passwordless authentication as well. The next is that we do automated service discovery, and Boundary is able to abstract away a lot of the friction associated with onboarding new resources at scale or dealing with dynamic services with continuously changing connection information. So administrators can automate these configurations and discovery of hosts and services as they are provisioned using things like Terraform. And lastly here, we get fine-grained visibility into sessions. So administrators have access into sessions through logs that are exposed in the UI or using an integration with your preferring logging analytics or data visualization tools. The session logs can then provide answers to questions like which identity accessed a system, and when did they access it, and when was the access terminated. So it's this last piece that we're going to be focusing on today, session visibility. We're going to take a look at the ability to record session activity and play it back with Boundary. So some of these features that you get by utilizing HCP Boundary or Boundary Enterprise is first, we get SSH target types. So these are some of the differences between using our enterprise level versions of the product versus our community editions. The SSH target type is important because when we're in the context of recording session activity, we need Boundary to understand what type of session activity it's going to be recording. And SSH target types is an example of how we understand what type of session activity we're interested in and how we can record it for playback and auditing at a later date. Additionally, we get access to those multi-hop scenarios with workers that we showed you before in the previous diagram. So if you want to set up chains of workers to provide deeper levels of network access, that's what multi-hop sessions give you access to. We also have the ability to inject credentials directly into user sessions so that end users or clients never have passwords for hosts exposed to them. You never expose your passwords to the end users, if possible. And that's what credential injection enables you to do. Lastly, with all these in place, you can perform SSH session recording, where we, again, have a record of user activity on a host, and we can play that back later on. So with session recording, we get a system of record to track session usage. You can have insight into your actions over remote sessions and respond to security incidents. And this just enables you to kind of review user activity for malicious behavior. If you need to go back and audit a session later on and see, okay, what did this user perform? Where did this security incident potentially occur? Then we can audit some of that user activity. And of course, this allows you to comply with your regulatory requirements. So These are some of the things we're going to set up today. The first thing is, if you've played with HCP Boundary before, we need to make sure that you're using HCP Boundary Plus to go ahead and enable session recording for your targets. And this will also allow us to set up an SSH target. And today, what we'll be playing with is a storage backend for these targets. So not only do we want to record activity, we want to store it somewhere. And in today's session, we're going to give you an opportunity to set that up with an S3 compliant storage backend. So here's kind of a reference architecture for you to keep in mind. This gives you just a little bit more of another way to visualize a little bit of Boundary's architecture. In particular, we have this control plane here. And this is, again, what's responsible for authenticate or authorizing a user to connect to the targets that we're trying to access down here. In this example, we have two workers that are providing access to your targets. We have an ingress worker that the client initially connects to. That might be in the public internet. That's just an example. But because of the way this reverse proxy works, we often don't have to have our workers exposed to the public internet either. When the client requests a connection to a target, the controller authorizes that, and the user then is forwarded. Its connection is a reverse proxy to the targets that we're trying to reach deeper into these networks. So this, again, is a way to just visualize how Boundary is working. But in today's session, we're going to simplify this a little bit further. We're going to use a single worker in today's session so that we're not here all day, and so we can just initially see what it's like to set up a worker. That worker is going to provide access to our targets, and it's also going to connect to our S3 compliant storage backend, which in this case is going to be min.io. So in this example, this worker is both routing our traffic to the targets, and of course, it's connecting to min.io to save session activity once the user has connected to a target and performed some actions. So that's kind of an introduction to today's content and what we're going to be doing. I'm going to give you a chance to fire up the tutorial content. You can scan this QR code, or you can visit the link that I have up on the screen. That is hashi.co/learn-boundary-recording, and pull up the tutorial for today's content. It's a step-by-step lab that you can also try at home if you prefer to do that there. The main things that you'll need to have in this lab are, again, access to HCP Boundary. You'll need to launch a Plus cluster. And then we'll need also Docker installed on your local machine. Now, if you don't have any of those tools set up, or you need some help getting them set up, you're welcome to call over one of our gorgeous TAs, wherever they are. We have Michael, Jeff, and Jim's here somewhere. And you can just call them over. They're here to assist you in any of this lab activity today. And now that I'm through with my speech, I want to encourage you to interact with us as well. So if you have questions, shout them out, raise your hand. I really want to give you a chance to use this time to interact with us and get your questions about the product answered too. All right. So was everyone able to visit that recording firstly, or the tutorial? Raise your hand if you were able to visit that link. OK, that's the first step, making sure you could get there. Yeah. Does everyone else have any burning questions before we dive into the lab itself? All right. So yeah, hopefully you can see a little bit about how this will work once we switch over to the lab here, in the sense that we're going to configure a worker itself, and we'll also tag that worker appropriately so we understand what is that worker's function and what is it doing for us. So we're going to switch over to my laptop screen at this point. Thank you. All right, and so here I have the lab content pulled up. I think most of you were able to visit this. I'm going to make it a little bit bigger, but off to the right you can see kind of a little bit of a overview of the steps that we're going to be going over in this lab as you walk through this material. So we'll just go through the process of getting set up. This will involve making sure that you have HCP Boundary properly configured, and then we'll go through the process of deploying min.io for our storage backend. And then we'll go through the process of creating a target and a worker and take an SSH recording and play it back. So that's the content for today's lab. I'm going to zoom in a little bit so you can see a little bit better what's on this screen. I'll be referring back to this to kind of make sure that we're all on the same page as we go through this. But the main thing here is to ensure that you have HCP Boundary up and running to get started. So in particular, Docker is going to provide the capability for us to deploy this kind of demo environment for us. So Docker will be required to do some of this. If you're not comfortable installing it or you don't have Docker, then you can try this later on or call a TA over. But it's going to what allows us to deploy our target, our worker, and min.io all locally on the same instance so that we can use HCP Boundary to provide access to that target. The rest of this here is kind of optional. You don't need JQ or Terraform. If you have the desktop app, that's great. If not, you'll have a chance to install it later on if you need it. All right. So we've gone through some of this background. There's a lot of good background material in here. And this is what I mentioned before with deploying HCP Boundary plus cluster. So I'm going to pull up my HCP Boundary portal here, assuming it allows me to sign in. And when you were inside of HCP Boundary, you probably saw a page with all the different services that you can select. And off on the left-hand side, you can click Boundary if you haven't seen it before. At this point, hopefully, you clicked the Deploy Boundary button. And this is what you need to make sure of, that you've clicked the plus SKU here. This is what gives you access to that SSH recording feature that we're going to try out today. I give my instance a name and then set a username and password. And then I'm going to deploy it. So here you can see it's creating this instance, and it'll let us know when it's ready. Is anyone having trouble signing up or deploying an HCP Boundary Plus cluster? Who was able to do it? That's a better question. All right. Great. All right, so we got a few people following along. So when this is finished, it'll let us know that it's up and running. The main thing that you'll need from this page in a moment is the cluster URL that you see over here. You'll need the ability to copy this. So you can always come back to this page and hit the copy button, or you can store it in your notes for later. But we will need access to this cluster URL, which will also be how we access the management page for our Boundary cluster, our controller, in just a moment. All right. So if you have that up and running, you're all set to proceed. And the next thing to do is to deploy a target and a worker. And again, we're going to use Docker to accomplish this. These images that we're downloading are pretty small, so I don't think you'll have too much trouble over the Wi-Fi, but I'll give you some extra time if these take extra to deploy. But the first thing we're going to deploy is a simple open SSH server container. And we're going to run this locally so that you can easily connect to this target. And we'll also deploy our worker locally as well. So to get started, you're going to copy this command. On all these pages, you can see this copy button next to the commands that I need you to run. So if you click that, you should be able to easily paste it into your terminal session. Now, before we get started, I think it's probably great to create a working directory that you're going to deploy most of this in. But the containers don't need to be deployed in that same directory. So to show you a little bit about how I'm going to do this, I'm going to head over to my terminal session here. And I just have a few different windows available to run these containers in and eventually tail some of their logs. So to do this, I'm just going to paste in this Docker run command and start an SSH container. The two things that I want you to notice here first are just that we're setting a username of admin. We're enabling password access. And then we're setting the password to password. Just a super secure container here. And outside of that, we're also setting up SSH access for this container on port 2222. That's just from the README. We're going to forward that to port 2222 on our local machine and deploy OpenSSH, the latest version. After you've executed that command, you'll be given the option to check that this container is running. This box a couple down allows you to run the docker ps command and format it. So if you click this copy button again and head back over there, you should be able to check and make sure that your OpenSSH container deployed successfully. Anyone have trouble with that? OK, great. Now, if you're going to follow along, we've provided a few different ways that you can complete the lab content. We have the ability for you to do most of the lab content using the UI, using the CLI, or using Terraform as we go through the tutorial. So you get to pick the way that you'd like to deploy this. Some environment variables may need to be set. So if you, depending on the workflow that you choose to use, you may want to copy the OpenSSH password and export it as an environment variable. So if you choose to follow with the CLI workflow, that's why we've pasted that for you there. And at this point, if I scroll down, you're going to find the next piece of configuration that's required to deploy a worker. Now, this worker is, again, going to provide access to two components in today's demo. It'll provide access to this OpenSSH target container we just deployed, and also to our MinIO storage backend. Now, I haven't talked too much about MinIO. I want to mention here that Boundary is facilitating access to S3 compliant storage. And the MinIO plugin is how we're going to set that up. But other S3 compliant storage also works with Boundary. So for example, Hitachi is another common S3 compliant storage backend. And the MinIO plugin also allows you to use Hitachi storage. So keep in mind, these steps are kind of for a generic S3 compliant storage backend. We have another tutorial that you can try out as well, session recording with AWS and Vault, if you want to try the S3 storage integration itself with Amazon S3. Regardless, when you deploy a worker, you're going to use a config file just like this. So today we're going to deploy a worker using Docker. So what I'm going to need you to do is create a config file, and you're going to need to follow these steps pretty precisely. Firstly, you're going to create a new config file in some working directory where you want to work for this tutorial. And you're going to name this file config.hcl. Now, I can pull up the README for the HCP worker container that we're going to deploy. It's the Boundary Enterprise Docker container. But the steps in the README essentially want you to call this file config.hcl. So that's why we're naming it that. It must be called config.hcl. And for the purposes of this tutorial, I'm going to go ahead and work out of this directory that I've created just in my home directory called learn boundary session rec minio. You can create any directory you'd like, but inside of this directory, I would like you to create a new file, config.hcl, and then open that inside of your text editor of choice. After you've done that, we can just talk through a little bit about what's happening in this worker file. So firstly, you'll notice that we have the HCP Boundary cluster ID field. So if you're using HCP Boundary, this is a unique field for configuring your workers to connect to HCP Boundary's control plane. With multi-hop scenarios, you can configure the other workers a little bit differently. But because we're using one worker that's acting as both our ingress and our egress worker, this is how we're going to set up this file with the address of our worker inside the file. So we're going to need to paste the ID of our cluster in there for that top field, and I'll show you how to grab that in just a moment. Next, we're going to set up some listener fields for our worker. So what port is it going to be listening on, and what purpose does this worker serve? It's a generic kind of proxy worker. It's providing access to additional targets or workers. And so we set its purpose as proxy, and then we're going to set its address. It's going to be my local host, and it's going to listen on port 9202. That's kind of the standard port that we usually configure workers to listen on. Next, we have this worker configuration. Now, in this, I'm going to set the public address of this worker. You can address your workers in a few different ways, but really you don't need to provide a public address if you've set up the configuration for a reverse proxy. But in this example, I'm setting the public address so that inside of HCP Boundary, you're going to see this public address for this worker reflected inside of our portal, and you can easily see which worker we're talking about in today's demo. I'm also providing an auth storage path. This is simply where it's going to store its configuration inside of the container. And the recording storage path inside the container where it's going to record our session activity later on. So you can see some of these fields are configurable. If you prefer to store your recordings in a different location that's not in the temp directory, which is recommended, you would configure that there. Lastly, the most important thing I want you to notice in this config file are the tags that we're associating with this worker. Now, these key value tags allow us to define what the purpose of our workers are. And so this is an easy way for you to delineate what is my worker, what function is it accomplishing, what is its purpose. And that way you can track what your workers are doing and also assign them using Boundary later on to fulfill specific purposes. In this example, this worker's doing double duty for us. I mean to say that it's going to connect to our storage backend, and it's going to connect to our OpenSSH target. You could have other workers that facilitate access to Vault, for example. So if you wanted to check out how to use Vault to provide the credentials for the hosts you're going to connect to, you might tag your worker with a Vault tag to help you understand what the function of that worker is, what it's providing access to. All right. So what are you going to do in this file? The only thing I need you to do is replace the cluster ID. So to grab the cluster ID, if you were to head back to your HCP Boundary portal dashboard here, you'll notice that cluster URL I wanted you to copy earlier. If you hit the copy button and head back into your text editor, if I were to paste this entire URL string, everything before the .boundary.hashicorp.cloud is your cluster ID. So we simply need to extract that value and paste it into that HCP Boundary cluster ID field. So I'm going to cut that, erase that string, and paste it in here. And that's the only configuration that you'll need to make inside this file. Go ahead and save it when you're done. Now we're going to get ready to deploy it. So beneath the configuration here, you're going to be able to copy and paste the Docker run command. The important things here is we're just defining that we want to use the host network. We're setting a host name for this container of minio-worker. And we're also going to set this directory structure. This is defined for us in the Boundary Enterprise container README as well. Essentially, we're going to be able to copy the config.hcl file we just created into the container, which is then going to run the Boundary server command and utilize our config file we just made. So the Boundary Enterprise container is going to allow us to deploy this worker locally, where it's going to facilitate access to our target. So as long as you run this in the same directory as your config.hcl file, you should be good to go. So I will make sure that it's in this directory and run this command. All right. Now you're going to get a lot of information here saying that this node is not yet authorized. It's essentially printing out over and over again, I'm not authorized. I have not connected to an upstream controller. I don't know what my function is. If I scroll up to the top of this output for this worker, to the very beginning of this command that I ran, scrolling slightly down, you're going to see this worker auth registration request. This value is what we're going to use to authenticate our worker to our HCP boundary control plane. There are a couple different authorization workflows you can use for workers. This is just a really simple one that we use where we print the key that the worker needs to connect to the upstream controller right inside the terminal. So it's easy for you to copy and paste this value into your HCP boundary cluster next. Yeah, the other trouble here is we need to go ahead and understand what our controller URL is. So the other piece we need to know is where does your controller live? And so that's some intelligence we would have to build to make that happen. To understand a little bit more about how this works, we're now going to access our HCP boundary cluster. So back from your portal here, or you can just take the cluster URL that you copied. Same thing, you can copy or open this admin UI by clicking this button here. This is going to take you to the administration page, the HCP Boundary Admin UI. And this is where we can actually speak with HCP Boundary. So I'm going to click here in the login name and type in the username and password that you created whenever you launched the cluster within the HCP portal a moment ago. So that same username and password. And when you log in for the first time, it's going to take you through this kind of startup workflow where it asks if you have a target you're trying to connect to HCP Boundary. So for first-time users, this is a really great onboarding workflow to say, hey, you want to try Boundary out? Put your target's IP address in here, give us the port you want to connect on, and we'll create this target for you. I'm going to have you skip this entire workflow to give you a little bit of a tour, set up this first configuration, and then proceed. So you can just click Do This Later. And now we're inside of the HCP Boundary Admin UI. I'm going to use this UI mostly to configure for today's talk. You can do all the same work with the CLI workflow I've created in the tutorial as well, or the Terraform workflows if you wanted to try that out. But we're very proud of our UI, and we want to show it off. No. So inside of here, notice, firstly, the main thing you want to pay attention to is what scope you're in, beginning with. Scopes are a way for us to logically organize our boundary resources inside of this interface. So scopes are a big part of what you want to pay attention to. In the global scope, you're going to have access to our session recordings, our storage buckets, storage policies, and aliases and workers. So these are really important ways for you to access these components we need to configure in the beginning here. So from this global scope, if you ever need to get back to it, you can click the boundary button here and click on the Workers tab. Now, when you launch this cluster, you get two workers that are managed by HCP. And these workers, again, live inside of the boundary control plane itself. So if you have a public target that's available, on the public internet or something like that, you can use these workers to easily route traffic to it. And you can also connect these workers to your managed workers as well. But for our purposes, we're going to create our own self-managed worker to get started here so that we can provide access to our targets running locally and our min.io storage backend in just a moment. So clicking this New button in the upper right-hand corner, it's going to take you through the configuration for your worker. Now, this is kind of just a getting started workflow that allows you to create this config file that we have in the tutorial for you. So if you ever need to generate this file, you can fill in those fields with the appropriate information, how you want to tag your worker, your cluster ID, all that stuff, and it will generate that config.hcl file for you. We don't actually need to do any of this because we already created the config file, we've already deployed the worker, but the instructions for doing all those steps are right here inside the UI for you, so you don't have to remember them in the future. This third step is confirm the worker when they connect, and you'll see it's asking for your worker auth registration request. And so this is where I want you to paste that token that you copied from the CLI. So again, this worker auth registration request field, copy that, paste it into this UI box, and click register worker. And it should immediately confirm that the worker was successfully added. If you click the Done button, you should now see that you have a new worker listed in your workers portal here. And if you don't see that it has 2 tags or you don't see the address yet, you can click the refresh button and it should have established contact with your worker. You'll notice here's the address that we put inside of our config file. So we've named it with the host name so that it's easily addressable. And it's set to contact it on port 9202. And if you click on the worker ID here, you'll notice there's a page called tags. If you click on the tags page, you'll see those 2 tags that were defined inside of that config file. So you remember we set the tags as min.io and OpenSSH. So if you deploy the worker using that config file methodology, you'll see your tags reflected here. And this is important because we're going to use these tags to set configurations for our target later on. You want to have trouble registering your worker? All right. So the last piece that we need to really put in place is the min.io storage backend. And this is just where we're going to store our session recordings after they're created. So we're going to deploy a third container, which is a min.io container. And to do this, following along with kind of the documentation for min.io, which is an S3 compliant storage backend, they want you to create this directory called min.io and data within it. So this is just in your home directory. You're going to run this command to create /min.io/data in your home directory. So you can paste this command anywhere. And when you're all finished, you should have this min.io data directory created. All right, so min.io data, some of you have probably pushed ahead. But at this point, you can deploy min.io because we have that data directory created locally where it's going to store those session recordings. So deploying this, the only thing you really need to pay attention to here is that we're going to open up a couple ports for min.io, and we're going to set a password and a user, root user, and a password of changeme123. That's just pulled straight from min.io's docs, so we like to keep those the same. So deploy this container after you've created that data directory. All right. So I've deployed both of these containers. We should be good to go at this point. And if you want to check that all 3 containers are up and running, we have a command for you that can print all the containers that you have running here. So we should see 3. Now at this point, we're ready to configure min.io, which is our storage backend. It's very similar to S3 in the sense that we need to create a storage bucket. We need to configure some policy on it. And then we should be ready to get a key that we can use to have Boundary store recordings inside of min.io. So to do this, we're going to open up min.io's admin console just by opening this localhost address at port 9001. And so you should see this whenever you've deployed the container successfully. You'll remember that password is printed when we launched the container. It's all caps root user, and then all caps changeme123. And after you've logged into min.io, you should see a very simple URL that we can use to set up a storage bucket. So inside of here, you can follow the prompts or visit the buckets page to create a new bucket. And inside the tutorial, I do recommend that you just go ahead and use the same names that I've recommended for you inside of here. You'll create a new bucket, and you want to give it the name Boundary Recordings with an S. You can change this, but the configs that we have later on depend upon the name of the bucket. So if you do give it a different name, just be aware you'll have to update some stuff later on. So create a name for your bucket. And then click Create Bucket. Next, we're going to create an access policy for this bucket to state who's allowed to access the bucket and what they're allowed to do to it. So you want to copy this IAM policy document. Just leaving this up on the page for a moment, what are we doing, right? We're effectively going to allow Boundary to do these things. We're going to allow Boundary to go ahead and view the recordings that are stored inside of our bucket. So you can see this star that exists inside of the Boundary-recordings policy here for this resource. And then we're also going to allow us to list all of the things that exist inside of this bucket. So this is really just setting a policy that allows us to view and then manage the recordings that we place inside of this bucket. And again, this is S3 compliant storage, so it uses the same exact versioning policy here that you'll find in S3. So after you've copied this, the instructions are going to have you go ahead and set up the Boundary recordings access key. So back in the min.io policy, the min.io console, you're going to click on access keys in the left-hand side here, and you're going to create a new key. You should see that you have no keys here. If I click create access key, you're going to give your key a name, and I think I'm going to call mine boundary-admin is what the tutorial recommends. And the main thing here is to toggle this switch that says restrict beyond user policy. So this is where you can paste in that policy statement. And so I'm going to select everything in there and delete it and paste in the policy that you copied from the tutorial. And now at this point, you're ready to save this user's versioning policy. So you can scroll down and click Create when you're finished there. And again, if you change the name of the bucket, that's where you would have to update the name of the bucket is inside of that policy. So I should have mentioned that. Now, this is going to display your access keys. You have a couple options here. You can download this key for later use, or you can make sure that you copy both of these for use. We'll need them inside of Boundary in just a moment. So ensure that you copy the access key ID and the secret access key there, and you have them somewhere safe. I'm going to check my paste stack here, and I do have both of those copied. So once you have both of those available, we are good to go. Now we're ready to finally set up Boundary. So, everything up until this point has been just some prerequisites of what you would need to have in place to do this. You need targets that you want to access with Boundary. We need workers placed in the networks that allow you to facilitate access to those targets. And there's a lot more to learn about workers in the future. And lastly, we need a storage backend to store those recordings in. So with all those pieces in place, we're ready to configure Boundary. So to do this, we'll first need to create a set of credentials for the targets that I want to access. These live inside of something called a credential store and a credential library. I'll then configure the storage bucket where I should store recordings. And finally, I will set up the target that I would like to access. So inside of here, you have a few different workflows you can follow. I'm just going to follow along with the UI workflow, but you're welcome to use the CLI or even Terraform. And inside the admin UI now, you're going to create an organization and a project. Now, inside of this admin UI, you remember me mentioning scopes before, up here in the global scope. If I head back to the top level here by clicking the Boundary button, you'll see that I don't have any orgs. Orgs are a way to scope our resources logically inside of Boundary. So if I click the New button here, I can create a new org level scope. And I'm going to call this, I think it's called in the tutorial, SSH recording org. It really doesn't matter much what you choose to call this at this point. But this is where you might create different orgs according to how you've structured your organization. You might have a billing org, or you might have a databases org, or you might have a dev org or a test org, however you want to structure those organizations. And after clicking Save, I've now created this new org that I can access using this drop-down in the upper left-hand corner. Within this org, we can then further scope our resources by creating something called a project. And your targets and your credentials live inside of projects within your orgs. So if I click on projects now, I'm going to have you create a new project inside the org, the SSH recording org you just created. and I'll call it ssh-recording-project. Once you click Save, this new org is going to be automatically selected for you from your scopes. So you can see I am located inside the SSH recording org and inside my new project here. And on the left-hand side, you'll see that some of our pages have changed for what we have access to. At this point, we're able to set up targets, and we're able to set up credentials for those targets. In a more dynamic environment, you create something called a host catalog that might automatically discover hosts that you have in your cloud provider. So if you were going to pull in your hosts from AWS, you would use a dynamic host catalog to do that. So we got some great tutorials that teach you how to do that if you want to learn about it. For today, we're going to just set up a simple credential and a simple target to show off how this works. So clicking on the credentials stores page here, you'll click the New button and create a new credential store. I think the tutorial calls it something like, looks like I skipped ahead a little bit. Nope, I didn't. SSH credentials. We're not going to connect it to Vault today because we don't have a Vault cluster deployed. So we'll click a static credential type and click Save. Now within credential stores, you can have multiple sets of credentials. It's a way for us, again, to kind of scope access to our credentials. So you could set up RBAC to provide access to a set of credentials for a set of targets or hosts. So within our credential store, we'll create our single credential by clicking on the Credentials tab and then clicking New. Inside of here, I believe we'll call it SSH, OpenSSH-creds is what the tutorial recommends. And scrolling down, you'll notice that you could use a key pair if you wanted to for your SSH key, or you could use a JSON blob if you wanted to as well. You'll remember for the username and password for this container, we simply called it admin, and we had a very secure password of password. And that was for that OpenSSH container we deployed at the very beginning. So filling in those fields, ensuring that you have username and password selected for the type, and clicking Save, you will now see that we have a single credential, and it's type, username, and password. And we're going to use this for the target that we set up in just a moment. All right. So if you're following along, next we're going to create a storage bucket. So this is where Boundary should store those session recordings. Now, to get back to the storage buckets, you'll need to be in the global scope. To do that, you can just click the big red Boundary button. And you'll notice on the left-hand side here, you'll then see storage buckets. Clicking on that page, you can add a new storage bucket. And the tutorial calls it SSH test bucket. Call it anything that you want. Scrolling down, you'll want to select the scope that should be used for this bucket. So we've created that org, and that's where our recordings are going to be associated with. So I'll click the SSH recording org as my scope, and now we have a couple providers listed. Now, if you're using Amazon S3, definitely select that provider. If you're using an S3 compliant storage backend like Hitachi or MinIO, you'll select MinIO as the provider here. Now in the tutorial, we've scoped these things out for you for how you can access MinIO storage. If you check out MinIO's backend docs, you'll find that we opened up port 9000 for the MinIO container as our endpoint URL. It's just where we ping the storage backend for MinIO. So copying that in, you're going to use that for the endpoint URL for MinIO. And the bucket name, this is what you'll want to make sure matches as well the bucket that you set up in MinIO. It must match exactly. So that was boundary-recordings with an S in my case. We don't have a region defined here, and if I scroll down further, I will paste in the access key ID and the secret access key that I copied from MinIO when I set up that access policy. So it's what was printed right here for you. So pasting those in. The last things that we need to do are define a worker filter. So you'll remember me mentioning and harping on tags for your workers. You'll remember when we deployed the worker, we had a tag that we defined for it. And tags are, again, a way for us to define what's the purpose of this worker. What is it going to accomplish for us within Boundary? You might add the networks that that worker is going to live in. You might add whether that worker is going to provide access to Vault or something like it. In this case, we're providing access to MinIO. So that's the worker that we want to select, even though we only have one in this example. So in the tutorial, we show you the worker filter format. We have a bunch of docs pages explaining the worker filter format for you. But copying and pasting that in, you can see we're going to search for workers that are named MinIO in its tag type field. So this key value pair for our worker, and that's going to resolve to workers that are tagged with MinIO. Yeah? Can we have a drop-down list? I'm not sure that we can, because you can select workers by multiple different things. You could select them by name. You could select them by any key value pair that you set up for them.
It's like a search field, like when you put MinIO tag, you get that one.
That's a good question. Yeah. I'm sure we could improve this in the future, but that's a great idea.
What if you have 100 workers?
If you have 100 workers, then you want to select the workers that are tagged with those tags. So it could be pretty intense, right, to go ahead and filter through them in a UI. A searchable one could be a useful way to do it. Mm-hmm. Lastly, check the Disable Credential Rotation button and click Save. All right, we should see we have successfully set up this bucket at this point. And now we have a place to store our recordings. So finally, we can create a target within Boundary. This is a target that says, what are we going to allow users to connect to? We will name this target OpenSSH-target. We'll set a target address as our local host, because that's where this target is going to be resolvable by our worker. And you'll remember when we deployed the OpenSSH container, we set it to listen on port 2222. So with all those fields in mind, you'll remember that targets are available from the org that you've created. So if I click on the SSH recording org scope and then select the only project I have, SSH recording project, you'll get access to the targets page where we can create these targets. Clicking on that page, we can select new target. And from here, I'll give my target a name, which I'll call OpenSSH-target. And importantly, if we're going to set up SSH session recording, we need to click SSH target type. This is how Boundary understands what type of activity it's going to be providing a recording of. So clicking on the SSH target type and scrolling down, this is that 127.0.0.1 target address. You want to make sure you use port 2222 because that's where I have SSH configured. And scrolling down now, we'd like to select -1 for maximum connections. Not really necessary, but we don't limit the connections to this particular target. And under aliases, you can give your target an alias, which is a short name. Now, I don't know if we'll have time today, but in particular, you should remember that during today's keynote, we talked about transparent sessions, one of our latest Boundary features, which allows you to easily connect to targets using something called an alias. You can essentially replace kind of your VPN solution currently by having a Boundary client agent run in the background on the machines that you're going to connect to targets with. So creating an alias makes it really easy for you to just connect to targets using your client of choice. So if you do want to try that out, you would add an alias here. I could call this OpenSSH .target, for example. I think the tutorial recommends that. So you can name your targets separated by dots there. To do that, you'll click the Add button and then click Save. Now, I've created my target here. And the two things that it needs for recordings are, one, it needs to know, again, what worker it should connect to. So clicking on the Workers tab here, we want to add what's called an egress worker. If you had multiple hops to reach this target, you could add multiple workers in that worker chain. We need to know, again, the ingress point and the egress point for that worker, for that target. We only have one worker, so I'll select the egress edit worker field here. And this is where I might select the worker that, again, has access to this target. You remember that I tagged this target also with OpenSSH. Using that same kind of format for selecting which tag is appropriate for the worker, you could absolutely use the min.io tag here. But I'm thinking about, OK, which worker provides access to this target? And that's why I've selected this OpenSSH tag. Copying this value and pasting it into the egress worker field, I can save this value. And now you can see that we've defined an egress worker for this target. The final thing is to select an injected application credential. So the far right tab is how we define a credential that should never be passed back to the end user. We set this up earlier for us, where Boundary is going to inject the username and password for our container directly into our session so that it's never exposed to the end user. Clicking Add Injected Application Credentials, you'll see that OpenSSH cred that we created just a moment ago. You'll select Add Injected Application Credentials. And now, under the Details page for this target, we're all set up. Now, I'm going to click this target's, I'm going to select the targets page again, and you'll notice we have this new target created. If I click on its name here, looks like I had zoomed in too far, so you couldn't see the aliases field. Under its Details page, you'll notice there's a section called Session Recording. So if we want to enable this for sessions, you'll click the Enable Recording button and then toggle Record Sessions for this target. Now, under the Storage Buckets field, you can select the bucket you configured earlier and click Save. You'll notice here we have Session Recording enabled, and we have min.io as the backend selected there. And at this point, we are ready to record sessions. Now, there's a few ways you can do this. You can initiate a session from the CLI, or you can use the Boundary desktop application to initiate sessions. Now, if you have the desktop application installed, you simply need your cluster URL, and if you have SSO configured with Boundary, you would then log into Boundary using SSO. In this case, we have a fresh, new Boundary cluster with none of that configured, so we're just going to log in again with the admin user that we have for now. To do that, you'll again need your cluster URL. You can copy that from your portal again, or you can find it in your paste history. But essentially, you need to paste in the cluster that you would like to connect to, click Submit, and then paste in your login name and password. There's also in the tutorial instructions for connecting on the CLI if you would like. If I click Sign In at this point, I should then be presented with a list of my targets because the admin user has access to all of these targets that exist. I can request a session through Boundary by clicking the Connect button. And now Boundary has authorized a session to this target. You could take these credential options for this local proxy that was created and use your favorite SSH client. So you're absolutely welcome to do that. If you click the shell button here, you will then see that the shell was launched. Now, look at that. I'm immediately injected into this container. It says, Welcome to OpenSSH. The credentials were never passed back to the end user. They never had to copy and paste them. They were simply put directly into this shell session. And you can do something like, Hello from OpenSSH. When you're finished, I can end the session, and Boundary closes the connection. Coming back to my HCP Boundary cluster, my admin portal here, clicking on the Boundary button in the upper left-hand corner, you can visit the session recordings page. You should see a new recording now. It'll say completed, it'll show the target. If I click the View button next to the recording, I should see the recording details, including bytes up, bytes down, and you'll even notice a big play button here. Clicking on that, you will be presented with an ASCII cast where you can play back the session activity. In the tutorial, if you follow up on it and continue with it, you'll also see information on how to download the session recording and what's called a BSR file, where you can inspect the recording details in a little bit more detail to unpack them and then see some metadata about the recording as well. But this is an introduction to Boundary session recording. There's a lot more to learn here, right? How can you dynamically pull in hosts? How can you set up multi-hops to reach your targets in deeper network enclaves? And how to use RBAC to also limit the people that could access these recordings or even have access to see what targets they could connect to. So the boundary worm goes a lot deeper right after this. I hope this was a decent introduction to session recording for you. And if you do have questions, we can hang out either in here for a few minutes, I think, or you can also check us out at the education booth just around the corner if you have follow-up questions. I'm going to let you go at this point because I think I'm way over time. But thank you for being here today and for following along. And please do hit me up at the education booth if you have any follow-up questions or want to chat anything boundary related. Thanks, y'all. Appreciate you.